Hi, Michael. Professor Sebastian back with you to finish going over your second exam. So we stopped after finishing 13, so let's look at 14. So number 14, again, we need to use implicit differentiation here. So you take the derivative with respect to x of both sides. Now, you had this partially correct, so where is that? It must have been out of order. Let me go down and see. Yeah, so take derivative with respect to x of both sides, you get derivative of x of 6/7, 6x, x of minus 1/7, that's correct. Now y is an unknown function of x, so chain rule. So 6/7 y to the minus 1/7, but multiply that times dy dx. Derivative 37, 0. And then it's algebra to solve for dy dx here. So I did give you some credit for that, but do the algebra. You got to do the algebra to solve for dy dx, so it simplifies to this. And then the second derivative is the derivative of the first derivative. So now I got to use the chain rule here. So it's minus 1/7 y over x to the minus 6/7 times the derivative of the inside. So low d high is x dy dx minus high y d low, derivative of x is 1 divided by low squared. Then you take what you got for dy dx and plug it in here where we wrote dy dx. Then simplify. Make sure you get the exponents of y and x as simplified as possible. Okay, 15. So here we go with another needed implicit differentiation because it says find the slope of the curve. So we can't solve this for y. So to find the slope of this curve, we have to do implicit differentiation and solve for dy dx because the slope of any curve is the derivative. So you did this right. You took the implicit differentiation right. Now you got to solve for dy dx. So just bring every term with dy dx to the left side and factor out dy dx. Put the terms without dy dx on the right side. Then you divide by the 18y squared minus 5, and there's your dy dx at any point. So it wants it at the point 1, 1, so you just plug it in. And there you go. All right, 16 was all correct. 17. So 17 says we got y equals some function of x, so find dy. Well, dy is f prime of x dx, so we just have to find the derivative of this guy. So this is a product, right? A function 3x times another function square root of 6 minus x squared. So we have to use the product rule. So first times the derivative of the second plus the second times the derivative of the first. Work it out, simplify it. There is your derivative, simplified. So you were trying to distribute the 3x in here. You can't do that when the power is 1/2. You can't just bring it in like that. All right, 18. 18 was a related rates problem. Somehow you got this first part right. There really is no work. You just wrote, I don't know, tree problem probably is what you meant. But oh no, it is a tree problem. So maybe you had a way of doing this without calculus. But if you understand the second part, then you should be able to understand the first part. So the estimated change in area, right? So we want to know about how much did the area change. In other words, what is dA dt? So I need to know A in terms of the diameter. So A is pi r squared, but r is d over 2. So it's pi times d over 2 squared, which if you simplify that, pi times d squared over 4, so pi over 4 d squared. Now, I need dA dt, so take the derivative with respect to t on both sides. So you get pi over 4, and then times the derivative of d squared. So you gotta use the chain rule, so 2 times d, and then times dd dt. So it's pi over 2 d dt dt. So we know what d is, it's 12. We found dd dt in the first part to be 1 over pi, that's how you got 0.3183. And then this simplifies to 6 square inches. All right, so that was 18. 19, I'll write on your own, 20. So 20 you didn't show me any work, but you have a partially correct here, and I'm not sure where you got the -9 because it actually comes from the critical point. You didn't show me that work. So, but how do you do a problem like this? I have a function. I want to know its absolute maximum and minimum value on a closed interval. In other words, where we include the endpoints. The thought process is I just need to check the function at the endpoint, at each endpoint, and then any critical points that are inside this interval. So first of all, find the critical points. Take the derivative, set it equal to 0. you get x equals 0. That's a critical point that's in the interval. So you check the function at the endpoints and the critical point. And you see that the absolute min is -9, but it occurred at x equals 0. So without the work, I'm not sure how you did that unless you just did it in your head. And then the absolute max then is this +7, which occurred at the right endpoint. 21 and 22, you got right on your own. 23, there's no work, but I want to explain this to you. So suppose f prime of x is 2x for all x. We want f of -2. Well, if you want to know the function and you know the derivative, I got to think, well, what function if I take its derivative gives me 2x? So that's x squared. That one's easy to think of. So f of x is x squared, but I could add any constant to it, right? Because derivative of any constant is 0. So f of x is x squared plus c. It's a family of functions. So I need to know what c is to be able to determine what f of -2 is. Well, they give you different pieces of information. In part A, you're told f of 0 is 0. So you plug in f of 0, you get 0 squared plus c, so it's just c. But you're told that's 0, so that means c is 0. Right? In part B, you're told f of 5 is 24. So what's f of 5? Well, f of 5 is 5 squared, 25, plus c, so it's 25 plus c. But you're told that f of 5 is 24. That means that c has to be -1. Same in part C, you're told f of -4 is 17, so f of -4 is 16 plus c, which is 17, so c has to be 1. Once you know that, then you can figure out f of -2 for each. So it's always -2 squared, which is 4, but plus c. So 4 plus 0 is 4, 4 minus 1 is 3, and 4 plus 1 is 5. So that's how you do 23. 24 you had correct, so 25. 25, here we're given the derivative of a function, and we're asked to find the critical points. Well, in part A, you need to know that the critical points are where the function's derivative is 0 or does not exist. So we're already given the derivative. Set it equal to 0, that means the numerator. So x is 3, this is a critical point. And then also we have to know, does this not exist anywhere? Well, if I'm dividing by 0, it does not exist. So that means x equals 0 is also a critical point. So those are your two critical points. Then to answer parts B and C, you want to do the first derivative test. So set up a number line, put the critical points on it, and then see what the value of the derivative is outside those critical points. So to the left of 0, I'm going to check the derivative at -1. I see it's positive. That means the function is increasing from -infinity to 0. Between 0 and 3, I'll check 1. It's negative. That means the function is decreasing between 0 and 3. So it's increasing from -infinity to 0, decreasing from 0 to 3. That means I have a local maximum at x equals 0. And then here, after 3, let's check 4, I get positive. So that means that the function is increasing from 3 to infinity. So if it's decreasing before 3 and then increasing after, that means I have a local minimum there. So that would answer 25. 26 is already correct. 27. All right, 27. We have we're looking at the function sine of 11x. All right, and they tell you the interval from 0 to 2 pi over 11. So here's where you need to understand. Sine itself, sine of x, is 2 pi periodic. That means it looks like that wave function we know sine looks like between 0 and 2 pi. Well, the sine of 11x will look like that same function. It's just going to go between 0 and 2 pi over 11. So 0 to 2 pi over 11, we see the entire sine curve before it repeats itself. So half of 2 pi over 11 is pi over 11. And then half of that is pi over 22, so that makes this 3 pi over 22. So we know that we have local maximums at pi over 22 and 2 pi over 11, and we have local minimums at 0 and at 3 pi over 22. Okay, and then the derivative is 11 cosine of 11x. So cosine of 11x will look just like the cosine function between 0 and 2 pi over 11. But it'll have an amplitude of 11 instead of 1. So it's bigger, right? Looks like that, taller. So in other words, we're looking at graph D here, where it has the function and the derivative. Okay, and then 28 is the last one you don't have right. So 28 gives us a function. We want to find the local extreme and inflection points. So extreme points, maximums and minimums, we need to find critical points. So you take the derivative, factor it, set it equal to 0. You see that -2 and 2 are critical points. So running the first derivative test, so like say x equals -3, if I plug in -3 into the derivative, I get 3 times -1 times -5, so that's a positive number. So in other words, positive over here, from negative infinity to -2, the function is increasing. And then between -2 and 2, let's say we'll check it at 0, so 3 times 2 times -2 is negative. So it's negative here, which means it's decreasing, so we have a local maximum at x equals -2. After 2, let's check it at 3. 3 times 5, 15 times 1. So positive. So it's increasing. That means you have a local min there. Okay? Now for inflection points, well, possible inflection points occur where the second derivative is 0. So if you find the second derivative is equal to 0, you get 0. X equals 0 is a possible inflection point. So inflection points are where the function changes concavity. So I have to check the value of the second derivative. To the left of 0, like say -1, I get -6. So it's a negative second derivative, which means we have a concave down function. To the right of 0, let's say 1, I get 6. That's positive. So to the right of 0, we have a concave up function. So it does change from concave down to concave up. That means that x equals 0 is an inflection point. Okay, that summarizes your feedback on exam 2. Mike, if you have any questions as you're getting ready for the final exam, please don't hesitate to reach out, and let's get that grade up to at least a B- if possible, all right? Okay, good luck.